Hello everyone, this video is about Chapter 9, Two Samples Hypothesis Testing. How to do hypothesis testing? The procedure is the same as one sample hypothesis testing in Chapter 8. Firstly, we need to frame the hypothesis, the non-hypothesis and alternative hypothesis. Then specify decision rule or the rejection region. After that, take a random sample of the population. Then determine the test statistic. Lastly, make the decision. HA is the alternative hypothesis. Usually, we put the claim in HA. H0 is non-hypothesis. For example, we compare the mean salary in two companies, Microsoft versus Facebook. Is there any difference in the two companies, or Microsoft has higher or lower salary than Facebook? Another example, we may also be interested in comparing the graduation rate in two universities, Harvard University versus Stanford University. Is there any difference between them, or Harvard has higher graduation rate or lower graduation rate than Stanford? In January, H0 we usually write as equal. HA depends on the claim. It can be smaller than, bigger than, or not equal to, the same as what we have learned in Chapter 8. The first two is one-tail problem. The last one is two-tails problem. Now let's see some claim examples. One claim is that Microsoft's average annual salary is lower than Facebook. Usually, we consider the first mentioned as 1 and the second mentioned as 2. So here, Microsoft is 1 and Facebook is 2. So mu1 is less than mu2 in HA, which is the claim. We write one more step as mu1 minus mu2 form. That is mu1 minus mu2 equal to 0 in H0 and mu1 minus mu2 smaller than 0, where here 0 is the hypothesis value. Another claim is that Microsoft's annual salary is more than 5,000 higher than Facebook. We write as mu1 minus mu2. We put the claim in HA, that is mu1 minus mu2 bigger than 5,000, where 5,000 is the hypothesis value. One more claim, that the graduation rate in Harvard is different from in Stanford. We consider the first mentioned Harvard as 1 and second mentioned Stanford as 2. In this claim, it is a hypothesis about the rate, proportion, so it is P. In HA, P1 is not equal to P2, which is the claim. One more step. We usually write as P1 minus P2 is not equal to 0 in HA, where 0 is the hypothesis value. Now, let's see the next steps. Specify the decision rule or the rejection region. We also use the curve plot to make a decision, the same as in Chapter 8. If HA is less than, the rejection region is on the left. If HA is bigger than, the rejection region is on the right. If HA is not equal to. The rejection region is on two sides. The cutoff are critical values, which we need to find later. Next step, take a random sample of the population and determine the test statistic, and then make the decision. Here we have 4 different cases, similarly as Chapter 8. Case 1, large independent sample means problem, where N1 is bigger or equal to 30, and N2 is bigger or equal to 30. The two samples are independent, which means they will not influence each other. We use z-table. Case 2, small independent sample means case, where N1 is less than 30 or N2 is less than 30. That means no matter how big one sample size is, if another sample size is smaller than 30, we consider as case 2. We use t-table. And case 3, large independent sample proportion case, where we use z-table. We have one more case, case 4, paired difference sample mean, in which the sample size is the same for two groups, and either paired observation or repeated on the same unit. We will see this case later. Let's see case 1 and case 3 first, because we use z-table. The formula for case 1 is as follows. The test statistic is a z-score, where x1 bar is mean of sample 1, x2 bar is mean of sample 2. D0 is the non-hypothesis difference, which is the number in H0 and HA. S1 is the standard deviation of sample 1, and S2 is the standard deviation of sample 2. The formula for case 3 for the proportion problem is as follows. The test statistic is a z-score, where P1 hat is sample 1 proportion, P2 hat is sample 2 proportion. Usually, for the proportion case, the difference value is 0. And P hat here is equal to x1 plus x2, and then divided by N1 plus N2. For case 1 and case 3, because we use z-table, we can use this rejection region summary table again to find out the critical values. For example, if HA is bigger than, we look at this column. If alpha is 0.05, we look at this row. The crossing is the critical value, bigger than 1.645. After calculating the test statistic, we need to make a decision. If the test statistic falls in the rejection region, reject H0. If the test statistic is not in the rejection region, do not reject H0, or we say accept H0. The other methods to make a decision using p-value and test statistic. The definition of p-value is the same as before. Probability in the tail associated with the test statistic. So p-value is probability. Probability in the curve plot is area. Here we only talk about case 1 and case 3 using z-table. If HA is less than, then p-value area, the starting point, is test statistic. No matter where it is, highlight everything on the left side. So the picture itself will tell you the area in yellow is 0.5 minus or plus the table value. If HA is bigger than, the p-value area in yellow will be on the right side. It is 0.5 minus or plus table value. Similarly, if HA is not equal to, the p-value in yellow is 2 sides, so you need to time 2 at the end. How we can make a decision? If p-value smaller than alpha, where alpha is always given, then reject H0. If p-value is bigger than alpha, then do not reject H0 or accept H0. In summary, we have learned 2 methods to make a decision. That is, reject H0 if the test statistic is in the rejection region or p-value is smaller than alpha. Otherwise, do not reject H0, or you can say accept H0. Case 2. For 2 independent samples, if one of the 2 samples, the sample size is smaller than 30, we consider as case 2. So the test statistic will be a t-score. The formula is as follows, where x1 bar is mean of sample 1, x2 bar is mean of sample 2. D0 is the non-hypothesis difference, which is the number in H0 and HA. SP squared is called pooled variance as this. Note that the degree of freedom is N1 minus 1 plus N2 minus 1. So it is N1 plus N2 minus 2. How to use t-table to find critical value? First, you need to decide it is a 1-tail or 2-tails problem. Then, select 1-tail alpha or 2-tails alpha as the column. The row is the degree of freedom, which is N1 plus N2 minus 2, and the crossing is the critical value. Consistently smaller than the rejection region on the left, bigger than on the right, not equal on 2 sides. How to use t-table to find p-value? First, if HA is smaller than or bigger than, it is 1-tail problem. Look at the row of DF, which is N1 plus N2 minus 2. On that row, find the 2 neighbors of the test statistic, and up to the 1-tail row range, the p-value will be arranged then. Similarly, if HA is not equal to, it is two-tails problem. Look at the row of DF, which is n1 plus n2 minus 2. On that row, find the two neighbors of the test statistic and up to the two-tail row range. Lastly, make the decision. Reject H0 if the test statistic is in the rejection region or p-value is smaller than alpha. Otherwise, do not reject H0, or you can say accept H0. Now let's see the last case. Case 4. Paired difference sample mean problem. It is compared the two means of two groups. First, the sample size for 1 and for 2 will be the same. Let's see the idea first. For group 1, here is the data. For group 2, here is the data. Now we add one more column, the difference. That is, each row calculate the difference. Like in row 1, it is x1 minus y1. For row 2, x2 minus y2, and so on. Now, we only consider the difference column so that we transfer a two-sample hypothesis problem into one sample hypothesis problem, which is Chapter 8 materials. Now let me give you some examples of Case 4. Like before versus after. It is repeated on the same unit. Imagine yourself compared to yourself. Like before, go to gym, and after you go to gym, your weight may change. That is, you compare to your own weight. We will only see the difference of each individual person. With versus without. With a traffic light or without a traffic light, the accident number may change. Repeat on the same unit. Like your family want to buy a house. You use 15 years rate or 30 years rate. Which one is better? You compare to your own family situation. This is repeated on the same unit. Or when you observe by pair. Then we can only consider the difference. The formula for the paired difference will be the same as in Chapter 8. If sample size of the difference is bigger or equal to 30, it will be a z-score. That is, sample mean of the difference minus the non-hypothesis difference value divided by the standard deviation of the difference and divided by the sample size. If the sample size of the difference is smaller than 30, it will be a t-score. The same formula. Remember, it will be a one-sample problem because we only consider the difference column so that the degree of freedom will be ND minus 1. Lastly, the same methods to make a decision. Reject H0 if test statistics is in the rejection region or p-value is smaller than alpha. Otherwise, do not reject H0 or you can say accept H0. After making decision, it is better to interpret the decision. How to interpret? If the decision is reject H0, we can see that at alpha equal to which percentage, there is sufficient evidence to indicate that the claim in HA. If the decision is do not reject H0 or accept H0, we can see that at alpha equals to which percentage, there is not sufficient evidence to indicate the claim in HA. In Chapter 7, we have learned the confidence interval formula and how to calculate the sample size. Here, let's extend all the formulas for two sample cases. Case 1. Large independent sample means. Here is the form of the confidence interval for the difference, where you can select the z-score for different confidence level, 80%, 90%, 95%, or 99%. X1 bar, X2 bar are the sample mean for 1 and 2. S1, S2 are the standard deviation for 1 and 2. Case 2. Small independent sample means. Here is the form, where SP squared is the same as before. How to find t-score in t-table? The column is confidence level. See it on the bottom of t-table. Row is DF, that is N1 plus N2 minus 2. Case 3. Large independent sample proportion. Here is the form where you can select the z-score for different confidence level. P1 hat and P2 hat are the sample proportion for 1 and 2. Case 4. Paired difference sample mean. If sample size bigger or equal to 30, use z-table. If sample size smaller than 30, use t-table. Note that it is one sample, only the difference. So, the degree of freedom, you should look at the row of ND minus 1. How to interpret the confidence interval result? We can see that we are 80%, 90%, 95%, or 99% confidence that the true mean difference or the true proportion difference of blah blah is between your result. Lastly, let's also extend the sample size formula in Chapter 7 to two samples problem. For mean, we may need to assume N1 equals to N2, otherwise we may not be able to solve the equation. That is the z squared times s1 squared plus s2 squared and divided by se squared, where you can choose the z-score for different confidence level. And SE is sampling error. Usually it's given. Either we say within a number or a width normal than, or half of the confidence interval width. Remember, at the end, you need to round up. Even 0.0001 you consider as 1. For proportion, we use this formula to solve the sample size for N1 and N2. Here, P1 hat and P2 hat are the sample proportion of sample 1 and sample 2. If they are unknown, we can assume it as 50%, 0.5. SE is sampling error, usually is given. Also, remember to round up at the end. That's all for this video.